Welcome to YouTube channel scientific_math. Derivatives and the shape of a graph. This is our main topic and the learning objectives. I will discuss the fourth point of the learning objective second derivative test. In previous lectures we have already discussed the key points regarding the local extrema, first derivative test and the concavity and point of inflection. I will provide the link in video description. You can watch. Okay. So let's move toward the second derivative test. How we can use the second derivative test to find the local extrema, means local maximum value and local minimum value of the function. Okay. So the first derivative test provide an analytic tool for finding the local extrema value, but the second derivative test can also be used used to locate extreme values. Using the second derivative can sometimes be simpler method than the first derivative. Okay, so we can find the local extreme value and the local minimum value of the function using the second derivative test, and it is a simpler method than the first derivative test. I have already discussed the first derivative test, how we can find the local maximum and the local minimum value of the function using the first derivative test. I will provide the link in video description. You can watch about the first derivative test. Okay, so we know that if a continuous function has a local extrema, it must occur at a critical point. However, a function need not have a local extremum at the critical point. Okay, so now let's start to discuss the second derivative test. What is second derivative test? Okay, suppose the first derivative of the function at some point c, that is critical point, is equal to 0, and the double derivative of the function is continuous over an interval containing c, and then this it's mean if we have interval ab, okay, and c is belongs to this interval. Yes, then what will happen? Okay, first point, that is if the uh, second derivative of the function uh, at c is greater than 0, then the function has local minimum value at this critical point c. Second point we have, if the double derivative of the function or the second derivative of the function at and this point c is less than 0, then the function has a local maximum value at c. Third point we have, if the second derivative of the function at c is equal to 0, then the test is inconclusive. Then what will we do when the derivative of the function, second derivative of the function is equal to 0? Then we move backward toward the first derivative to find the local maximum or local minimum value. And we know that how we can find the local maximum and minimum using the first derivative test. So we have an example, and example second derivative test. Okay, use the second derivative test to find the location of all extrema values for the given function. Yes, we will find the a local maximum and the local minimum value of the function using the second derivative test. Okay, solution. To apply the second derivative test, we first find the critical points c where the first derivative of the function is equal to 0. Okay, so how we can find the critical points? First we find the first derivative of this function, and then we put the this is equal to 0, and we will get the critical points. Okay, so this is the first derivative of the function, and we put this is equal to 0. Okay, and then we do some simplification, and we get the critical points where the first derivative of the function is equal to 0, and where c is equal to 0 means critical values. Okay, next we find the second derivative test, because we want to apply the second derivative test. So here we have the second derivative of the function, that is this one, and now we will find the value of the second derivative of the function at critical points, and then we will check whether the function is less than 0, function double derivative greater than 0, or equal to 0 at critical points. Okay, so here we have all the critical points. X is equal to minus 3, x is equal to 0, and x is equal to square root 3. Okay, so at this point, and the value of the second derivative of the function is this one, and at 0 is equal to 0, and square root 3, this is 30 under square root 3. So at this point, the function has a local maximum, and at x is equal to 0, the test is inconclusive, and when x is equal to square root 3, the function has local minima. Okay, so when the test is inconclusive, then what we will do? Okay, the second derivative test is inconclusive at x is equal to 0 to determine whether the function has local extrema, means local maximum or local minimum at x is equal to 0. We apply the first derivative to evaluate the sign of the first derivative, and this function, first derivative function, we will check the value and the sign of the first derivative around the point, around the critical point x is equal to 0, whether the function has the first function has positive or negative sign around this point. Is the function changing its sign from negative to positive, or positive to negative around this point? Okay, so first we divide the interval. Okay, we take the interval minus uh, 3 to 0, and next one is 0 to square root 3. These are two intervals, and we will take some arbitrary test point from this interval and from this one also. Okay, so and these are two intervals from minus square root 3 to 0, and 0 to square root 3, and these are the test points, that is minus 1 belongs to this one and positive 1 belongs to this one. Okay, so on both the test points, uh, from left side of the critical point 0 and from right side of the critical point, and the function has the same sign, the function does not changing its sign from positive to negative or negative to positive. This means the function is decreasing around this point, before this point and after this point. Okay, so, and this is the first derivative test. How we can find using the first derivative test. Okay. Again, I will provide the link in video description. You must watch the lecture about the first derivative test. Okay, so let's see this with the help of graph of the function. Okay, so here we conclude that f is decreasing on both intervals. Therefore, f does not have a local extrema value at x is equal to 0. So this is the graph of the function, and we can see that the function has a local maximum at this point and local minimum at this point. So here the second derivative of the function is greater than 0, and the second derivative of the function is less than 0, mean at this point the function will have local maximum, and at this point the function will have a local minimum. Okay, and we can also uh, see that in this interval, and the first derivative of the function is less than 0 from minus under root 3 to 0, and from 0 to under root 3. The first derivative of the function is less than 0, and this is the point x is equal to 0 where the second derivative of the function is the inconclusive, mean the second derivative of the function at x is equal to 0 is 0. Okay, so what will happen if the second derivative of the function is equal to 0? This mean this is the point of inflection. Point of inflection. And what is point of inflection? Point of inflection is where the function changing its concavity. We can see that, and here the function is changing its concavity. Here the function is here the concavity. The function is concave up, and here the function is concave and down. You can see, you can watch in the lecture related to the point of inflection. Okay, so this is the point here at which the second derivative is equal to 0. This mean this is the point of inflection, and at this point the function is changing its concavity. So this is the second derivative test for finding the local maximum and local minimum value of the function.